students. In this video today, we're going to be talking about how to draw and interpret cash flow diagrams. And I'm going to be using example 3-5 from your book, from chapter 3. And in it, it has a word problem. And this helps explain the why behind why do we need to draw cash flow diagrams. Well, this is a very simple problem, and we could represent this with a table. We could even bust out a formula in Excel for this. But as the problems get more and more complex, cash flow diagrams can help you understand the problem as it occurs in time rather than just looking at the entire problem at the same time, okay? So the way you read this problem here is if $500 were deposited in a bank savings account, how much would be in the account 3 years from now if the bank paid 6% interest compounded annually? Now we're going to make a couple of assumptions to simplify these cash flow diagrams. And one of the first assumptions is that whenever we refer to interest from here on out, this compounded is going to be assumed. Okay, so it's assumed, and the reason is because in chapter 3 they do introduce the concept of simple interest, and that's interest that's paid just on the original principal if you're paying back a loan. Okay, well, compounded interest means that as the balance is carried forward, any unpaid interest is added to that balance and computed, and you got to pay compounded interest. So you're paying interest on the interest. It's compounding over the top there, okay? So you won't see this written out much more after chapter 3, and you'll just assume that we're working with compounded interest, okay? Okay, so why cash flow diagrams get helps us understand the problem as it occurs over time, okay? And so what we're going to do is we're going to have the time element of the diagram go horizontally, okay? And we are going to start with a period 0, which represents today, okay? So here's our 0. Then there's going to be a segment that's going to take us to 1, okay? All right, so time 0 represents today or now, okay? All right, and you might say, well, okay, the next period might be here at 1. Well, this is actually the end of period 1, and the period actually refers to the interval, and so this would be period 1. Now, in this problem, we're going to represent the number of periods in which the interest is compounded annually by the number of years. And so this 3 is going to take on our value of n. So n equals 3 in this problem. And so we have to go to the end of the second period and the end of the third period, okay? So we've added our time element here, okay? Now, remember that this is period 1, this is period 2, this is period 3. So this 2 represents the end of period 2, and the start of period 3. Okay. Likewise, this is the end of period 1 and the start of period 2. Okay. All right. All right, so now that we've got that there, we've got the concept of the time, okay? All right, so the number of periods in which the interest is being compounded is 3 periods. The time is 0 all the way to period 3. Okay. Now, what about the flows? Okay. Well, when we're talking about money, okay, the cash flow is going to occur on the number, okay? And so we are going to assume that the accounts flow at the end of the period, okay? So we're going to assume, again, that the cash flow events occur at the end of the period. Okay? And so that's important why we have this end of the period here. Okay. So at this cash flow period, we are going to have an inflow of cash, okay? And this is known as a receipt. If we were to put these values on a table, it would take on a positive sign, okay? And then we have, pointing down, an outflow of cash. And this is called a disbursement. And if we were to draw this into a table, we would have a negative sign. Okay. All right, so now we are ready to add the cash flows to the problem, okay? So without the labeling here, we're just going to redraw the timeline here. 0 to 1 to 2 and to 3. Okay. All right. So in this problem, you are the saver. Okay, and so you're depositing $500 in the bank. You're going to leave it there for 3 years, and so you are dispersing this money. You will not have access to it until you withdraw it 3 years from now. And so this would be an outflow of cash pointing down. And we would call this amount $500, and we're going to call it P, representing the present sum of money. So $500 is deposited today, and in 3 years, at the end of the 3rd year, you're going to get a cash inflow, which is a future value or future sum of money, and we don't know what it is yet, okay? And so that's our cash flow diagram, okay? Now this is a very simple diagram here, in which we have one outflow and one inflow, okay? But it's possible to have outflows and inflows in periods 1 and 2, and it's also possible to have an outflow and inflow at the same time. Now you might be tempted to just kind of net those out, so you only have to draw one arrow for a net upwards for a net inflow, or one arrow downwards from an outflow. So for example, say in the same period, period 1, you might have an inflow of $50, but an outflow of $100, and so you'd have a net outflow of $50. So instead of drawing just one arrow, you still want to draw both, because it's going to make the problem easier to understand, especially if you apply different types of treatments to outflows and inflows there. Okay. All right, so back to this problem here. Now that we've drawn the cash flow diagram, we understand the problem fully, and we can apply a number of different solutions to this, okay? Now, I don't have a lot of whiteboard left, but the solution I'm going to show to you first is just the formula solution, okay? And so if we want to determine a future sum of money based on a present sum of money over a number of periods, 3, in which the interest is compounded annually, okay? So again, I'm going to put this down as the present sum. And the how much would be in the account. This part would be the future sum that we are trying to calculate. Okay. And the interest rate, I equals 0.06, is shown here. And so now we have a complete cash flow diagram. We have the number of periods, we have either the present sum of money or the future sum of money, and we're solving for the other, and we also have N and I. Okay, the number of periods was the interest being compounded, and the interest rate. Okay. All right, so now we can go on to the formula solution here. Okay. And so in this formula solution, we are going to use F equals P times 1 plus I to the power of N. So the future sum of money equals the present sum of money times the interest rate compounded over n periods. Okay? So we would just plug all these values in, and that is going to give you, let's see, I'll write it below here, F equals 500 times 1.06 to the third power, and that value is going to calculate to $595.50. Okay, so congratulations, you've done your first cash flow diagram, and from here we're just adding complexity, such as inflows and outflows occurring at the same time, increasing the number of periods, different types of uniform payments versus gradients, arithmetic stuff, you know, all that stuff. But it all starts with here, and so until you get really comfortable with solving these types of problems, I recommend that you draw out the cash flow diagram before you start picking formulas and plugging things in. Okay? All right, see you on the next video.